Exercise 12I4, question A. Y equal 4x square plus 6x. So this is a quadratic equation, a greater than 0, a greater than 0. So it has the minimum. Right? When x equals 0, y equals 0, it's going through 0, 0. And when y equals 0, 4x square plus 6x equals 0, then divide by 2, 2x square plus 3x equals 0, x is common, 2x plus 3 equals 0, x equals 0, we got this point, and x equal 2x equal minus 3, x equal minus 3 over 2. So another point is now 0, 0, minus 3 over 2, 0. Now we know this is crossing from y-axis, and this is x-axis. Those both points are same in this case. Now we need to find the minimum. There are two ways. One is taking dy by dx equals 0, and then you found out already that x value is minus 3 over 4, and relevant coordinate is minus 3 over 4 minus 9 over 4. Actually, let me work out this one. So y equal 4x square plus 6x. Then you take dy by dx equals 0. This is going to be 6x. 8x plus 6. At a stationary point, dy dx equals 0. Then 8x plus 6 equals 0. X equal minus 6 over 8 minus 3 over 4. And then you found out this one, this point, the y value is minus 9 over 4. Now we found out the minimum. So what is the other method we can do? This is only for quadratics. Complete in square. When we take 4 out, this is going to be x square plus 6 divided by 4 x, then 4 x square. This is, I can write 6 divided by 4, 3 over 2 x. 4 x plus 3 over 4 square minus 3 over 4 square. So this is 4 times x 3 over 4 square minus 9 over 4. 9 over, this is 16. 3 square 9, 4 square 16. Then this is 4x plus 3 over 4 square minus 4 times 9, 16. That is 4x plus 3 over 4 square minus 9 over 4. Now we can draw the graph. It is going 0, 0 like this. This point is minus 3 over 2, 0, x and y, and this point, the minimum is minus 3 over 4 minus 9 over 4. Partly, when x equals 0, y equals 9, 0, 0. So the graph will cut at y-axis at 0, 9. For x-axis, y equals 0. This is 9 plus x minus x square equals 0. I'm not going to work out this one. I'm going to leave it. But I know that minimum value from dy by dx, we found out maximum value of this graph because a value is less than 0, so it has a max. Indifferently, we work out dy dx, and we found out x equal half is the maximum, and relevant y value is so half a relevant y value is 9 1 over 4. So when we draw the graph, it will go through x is half and 9 over 4. This is half, this is 9 1 over 4. Graph is going like this. This point is half a 9 1 over 4. When we solve this one, we will get y equals 0, we know, a and b. So this is a0 and this is b0. X and y. So you may use the quadratic formula to use this one, to solve this one. Part C. So we want to sketch this one. When x equals 0, y equals 0, 0, 0, 1. So 0 and 1. So y-intersect is this graph 0 and 1. Now we want to find when y equals 0. Y equals 0, x cubed, x square minus x plus 1 equals 0. When I look at this one, I can see x square is common. So I will take this one, this is x minus 1. And I will take this one minus. So x minus 1. Now both terms x minus 1 is common. So then x square minus 1 is remaining. This is difference of square. So this is, you can write x minus 1, x plus 1 equals 0. So this is x minus 1 square, x plus 1 equals 0. Now there are 2 points, x equal 1 or x equal minus 1. So this is x equal 1 is a repeated root. We can write like this as well, x equal 1 or x equal 1 or x equal minus 1. So this is repeated. So we know that this kind of graph, when x goes to positive infinity, y goes to positive, and x goes to negative infinity, y goes to negative. we work out in chapter number 4 this kind of graph. So the graph is going to be um, something like this. So this is we found out 1 1 0, and this is minus 1 0 here. Now you can see this is a minimum and this is maximum. Now we need to find those minimum and maximum. So what is the technique? Now we can't use uh, any other techniques other than dy by dx. So y equal x cube x square minus x plus 1 dy by dx equal 3x square minus 2x minus 1. So to find the saturatory, we make this one equal to 0. So 3x square minus 2x minus 1 equal 0. So the bracket is 3x plus 1 and x minus 1 equals 0. X equal minus 1 over 1, 1 over 3, and x equal 1. Already, when x equal 1, 1 minus 1, we know this one minimum. So we got already this one. So this point is when 1 and 0, it is there. Now, when x equal minus 1, 3, y equal minus 1, 3 square minus cube minus 1, 3 square minus 1, 3 plus 1. This value will give 1, 5 out of 27. So now this maximum is minus 1 over 3, 1, 5 out of 27. Now the learning is now in this kind of graph, we can find the minimum and maximum using dy by dx differentiation. Part D. So in here, when x equals 0, y equals 0, this is going 0, 0. Then y equals 0, x times y equals 0, x times x square minus 4x minus 3 equals 0. X equals 0 or x square minus 4x minus 3 equals 0. Now this is a quadratic equation. By quadratic formula, you can find 2 points. So then this is x equals 0. From here you will get 0, 0. Already we have. We got two x values. Let's see a and b. Then it will cut. The y value is 0 because we took y is 0. And x goes to positive, y goes to positive, and x goes to negative, y goes to negative. Now you'll get this kind of graph going to 0, 0. So we know 1 point. This is 0, 0. This is a0, and this is b0, x and y. Now we want to find minimum and maximum. How do we find minimum, max, maximum? Dy over dx we want to find. Then dy over dx equal to 0, and we will get according to the equation. So this is a cubic equation. Cubic equation differentiate, you will get a quadratic. It means there are two answers. So y equal x cube 4x square minus 3x. So dy over dx equal 3 6x square minus 8x minus 3. So when you make it equal to 0 minus 8x minus 3 equals 0, you will get x equal minus 1 over 3 and x equal 3. So this is minus 1 over 3. We need to find the y value. This is 3. And when you substitute x equal minus 3 to this one or this one, you will get y value is 14 over 27. And when you substitute to this one or this one, you will get y value as minus 18. Question number 5. We don't need to find we don't need to sketch this one, but we want to find minimum and maximum. So what shall we do? As usual, we'll get dy by dx and 3x square minus 6x plus 3. Now to find the stationary point, we make dy by dx equal to 0. The place where gradient is 0. So 3x square minus 6x plus 3, this is equal to 0. I can divide by 3 because this side is 0, that's why. So x square minus 2x plus 1 equals 0. So this is x minus 1 square. It has only one minimum maximum or point of inflection. So that is x equal 1. So 1, and what is the y value? We'll find the y value here. Y equal 1 cube minus 3 times 1 plus 3. So this is cancelled out. Answer is 1. So 1, 1, we have a either max, mini, or point of inflection. Now we'll find what is. We can get the second derivative. So dy over dx is 3x square minus 6x plus 3. D square y over dx square is 6x minus 6 at x equal 1. D square y over dx square value is 6 times. We need to determine in this point, x equal 1 point. 1 times 6, which is 0. Okay, now according to the theory, f double prime x greater than 0 minimum, if double prime 0 less than max, if double dash 0, so this is d square by over dx square equal to 0, inconclusive. We can't take decision now. We're stuck on this part now. We can't do anything. Now we have to go to the second method. In the second method, we'll check the gradient now. So this is equal to 0. Hence, this is inconclusive. Right? Now we'll go to other method. Now we want to check the gradient. For example, if you are in a mountain, what do? You'll go and check. You just check the steepness of both sides, right? So likewise, we just go. We just check what will happen left and right of x equal 1. If you come bit to this direction and see somewhere, and you can come to this direction and see somewhere. Now x equal 1, dy by dx is gradient is 0. X equal 1, dy by dx is 0. X less than 1 in this area. Can you tell me a value? Yeah, you can find 0 here. So when I put 0 to dy by dx, so dy by dx when x equals 0, this is going to be 3, this is 0, minus 0 plus 3, that is positive. Now we'll check x greater than 1, this area. We can write like this as well, 1 greater than x, dy by dx, x equal 1, so this is going to be, will not 1, we'll take any value greater than 1, let's say 2. Actually best value is 1.01 or 1.11. We can't go very far because we will capture it with the other global maximum and minimum. But so with the calculator workings, we can put a 1.1. But I know that 2 also fine in this case, so I'll put 2. So then this is going to be 2 square 4. This is going to be 12. 12 minus 12 is it is positive. Let's put 3. 3 square 9, 27. So this is also positive. If you put any value x greater than 1, the gradient is going to be positive. Okay, now we'll draw the picture. This is a positive gradient, then negative 0, and again positive. Right? What is this point? Point of inflection. Hence 1 is a 1 is a point of inflection, and it is a rising one. This is a good example that the second derivative test always doesn't work. For some cases it's fine, but most of the cases it is fine. But for some cases like this is a good example. We have to switch to the second method. If you don't know the second method, then you can't get the marks. So you'll get a curve like this. So this is going to 1 1, also 0 0, because you know that when x equals 0, y equals 0, and x goes to positive infinity, y goes to positive, x goes to negative, y goes to negative, and that's all basically. So this is the point of inflection. Find the maximum and the range of values. Okay, first of all, the question is given, question give the point is a maximum, but still we have to confirm. Let's see. Now this is fx. So we'll find f dash x as usual. This is going to be 0 minus 2 times 4 times x3, which is minus 8x cube. For stationary point, we want to make f dash x equals 0, which is dy by dx same. Then minus 8x cube equals 0, x equal 0. So when x equals 0, what is the y point? When you put 0 here, that is 27. Now I want to decide this point is whether minimum, maximum, or point of inflection. Three options. Now I will take the double prime. Um, Prime is 8x cube. So this is double prime is 16x square. Then we need at x equals 0. When x equals 0, if double prime is minus 16 times 0, 0. Now test is inconclusive. You can't decide when you get this 0. Then we have to go on the second technique. What is, we know already second technique is now number line. We are breaking into three pieces, two pieces. One is 0, before 0 and after 0. By dx. Now it is f dash x. So I will stay with this one. F dash x. X less than 0. X equal to 0 and x greater than 0. So in this point, x less than 0, f dash x. So this is negative. This is, we know that dy by dx is 0 at this point because we make it to 0 and found out. And here, okay, we don't know this is negative. How do we find this one? We'll take any value less than 0. Let's say minus 1. We can't take actually any value. I can't take minus 10,000. I want to take a small distance. That's how we want to tell that. So basically minus 0.1 minus 0.1. We want to go delta x. Delta h was in h. X plus h. F dash x plus h. And f dash x minus h. This h is a very small distance. However, I will put minus 1. So f double dash dash f prime minus 1 equal minus 8 minus 1 cube, which is positive. This is positive. Now x greater than 0, I will put 1. F dash 1 is minus 8 1 cube, that is negative. So this gradient is positive, this is 0 and this is negative. So what is this point? This point is a maximum point. So 0, hence 0 27 is a maximum point. So now what is the range? When you draw this graph, you can see 0 27. So range is, so what are the values it can take, basically that is the range. You will learn this one year 2 chapter 2. So range is fx less than or equal to 27. Range mean when you insert x values, what are the values y can take. So y can take any values less than 27, equal or less than to 27. Question number 7, we need to find the gain stationary point. So the process is we want to find the first derivative, then at the stationary point f dash x equals 0. So 4x cubed plus 9x square minus 10x minus 3 equals 0. Now this is a bit challenging. Now we want to go to chapter 2, chapter 7 to techniques. Chapter 7 techniques to factorize. So if I take this is gx equal 4x cubed 7 9x square minus 10x minus 3. When you put g2, will now trial and error. So we want to put g1 x equal 1 x equal minus 1 2 minus 2 3 minus 3. Hopefully 1 should be work. Let's see. We'll start 1 g1 4 plus 9 minus 10 minus 3. 13 minus 13 equals 0, right? It works. So x equal 1 work. It means x minus 1 is a factor. So we'll divide this one 4x cubed 9x square minus 10x minus 3 by x minus 1. So this is going to be 4x square. This is 4x cubed minus 4x square. That is 13x square. When you minus those two, minus 10x minus 3, then plus 13x. So this is 13x square minus 13x. Then when you minus, this is going to be 3x minus 3. So then this is going to be plus 3. So then 3x minus 3 equal, when you minus this one, 0. So now you can write gx equal x minus 1 times 4x square plus 13x plus 3. Now this is, we can break x minus 1, 4x square plus 13x plus 3, 4x plus 1 and x plus 3. Now we factorize this one. Now what is the factorization? X minus 1, 4x plus 1 and x plus 3 equals 0. Now we'll go from that point onward.